Hey, can you hear me?
I can hear you. Can you hear
Oh,
me?
yeah, loud and
Great,
clear. Nice.
great. Let me try to share my screen to have the whole setup
Yeah.
done.
So we will wait until 2 o'clock and we will
All
start.
right. Yeah, no rush. I should even wait for a couple more minutes after two for all the late people. Does it work well though? Can you see my screen?
Yeah, it works well. Uh, Thank you so much for taking the time to
Of
have this
course.
talk for us. We are really excited about it.
It's always fun. I always love it. I hope if that works for you, I won't spend too much time on the presentation because I usually get a ton of questions.
Mhm,
So yeah, I'll keep it on the shorter side for the presentation, and like that, we'd have a lot of time for questions.
for sure. Yeah. I think people will have lots of questions. Hopefully, we can have the time to answer those questions.
Yeah, sounds good. How have you been doing, man?
I
How's the West Coast?
the West Coast is awesome. How about East Coast?
East Coast depends where. New York is not awesome these days. I mean, yeah,
Really?
with like COVID, it's kind of tough, you know. Like if you have like a small apartment in New York,
Yeah.
kind of tough, you know, if you can't get out of your apartment or if you can get out just in the street.
Yeah.
We don't have as much like outdoors
Hmm.
as on the West Coast, you know, like in New York. So I went north, and now I'm in Connecticut for the summer, where I have
Hmm.
like more space, beautiful
Yeah.
nature, and all of that.
Yeah. It looks awesome.
Yeah,
Yeah. I really love San Francisco. Here, we have lots of space. The culture is interesting. And actually, we recently moved to a bigger house.
nice.
We are about to move to a bigger house
Oh,
near the ocean, so it's gonna be exciting.
nice.
Yeah, yeah.
And speaking of the talk, do you know more or less who is going to attend? What kind of background? What kind of people? Just for me to understand a bit what they would be interested in.
Yeah, for sure. So people who will attend are the public. We don't know who will attend, and I think most of our data scientists, and they might not have like uh, much familiarity with the current NLP developments, but they are definitely excited and curious about it.
Okay.
So yeah, I think we have some chat going on. Some uh, yeah, they say undergrad student in machine learning. Nice. So we're happy that you guys have joined us in this webinar. Yeah, so um, feel free to discuss anything that you find interesting, and keep in mind that some of the people might not have the whole context of what's going on in NLP right now.
Okay, I'll give them the context then.
Yeah, yeah, but definitely people are much familiar with machine learning concepts, and
Okay,
yeah.
okay, sounds good. Sounds good. I don't know if we did we retweet with the Hugging Face account.
I don't think so. I didn't see
Wait,
that.
let me retweet it maybe. All right, let me know
Oh,
if I put anything confidential on my screen. I think it's fine for the moment.
yeah, I think I see a retweet from Hugging Face, so
Ah, nice.
no worries.
Is it what's this one,
Yeah,
right?
yeah.
All right, yeah. Good. Slack. And so how much time? And we have around an hour, you think?
Yeah, an hour.
Okay. So maybe I'll do something like 15 minutes or 20 minutes of presentation before I'll stop before I start to bore people, and then can do the rest with questions.
Yeah.
By the way, if there are participants already, feel free to add your questions to the chat, and maybe we can take them at the end after the presentation.
Yeah, for sure. I'm sure your presentation won't be boring to our attendees. So
you never know, man. Don't take any bets.
Okay.
No, like the boredom is always on the eyes of the audience. You know, like
Yeah.
I think if people are interested in NLP, it's going to be interesting.
Yeah.
If they're not interested in NLP, might not be so interesting, unfortunately. There's not much I can do about that.
Yeah, it's really interesting that the excitement around NLP has grown so much on as a whole, and also in Stitch Fix since I joined.
Yeah.
So yeah, I think you guys had a big part in that. So
yeah, I mean, I remember like 4 years ago, you had to explain to people what NLP was. You had to say like natural language processing.
Yeah.
Because otherwise, people wouldn't know about it, and they knew already about computer vision, but NLP was so much behind. It caught up, which is great.
Yeah,
that's just the beginning. It's just the beginning.
Yeah.
Like in a few months, people will be like, computer vision. What is self-driving? What is that? I only know. I thought the only machine learning was NLP. Is there something else in NLP?
Exactly. I think your background was computer vision, right?
Yeah, I did computer vision like 10 years ago, a decade ago. Yeah. So I can say computer vision sucks. just kidding.
Yeah, there's not many papers interesting coming out from computer vision, or maybe I'm biased. I'm only focusing on NLP. What do you think?
It's hard for me to say really, because I've really been focused on NLP for the past few years, so I haven't been following computer vision so much.
Yeah.
So I don't know if I'm the best person to really talk about computer vision, but definitely caught up. What's really interesting to me is that you're starting to see more and more papers that start with NLP and are applicable to computer vision,
right.
Which wasn't the case before. It was more like the opposite, right? You would start with a computer vision paper, and then some NLP guys would try to replicate that for NLP.
Yeah.
We're seeing more and more transformers in computer vision. Seeing more and more of like multimodal, so using computer vision, but more to like ground language models, or kind of like complement language models, which I think is great. So yeah, I think, and I mean, interesting thing is that maybe they're just saying that to us, but when we talk to the PyTorch TensorFlow team, they're also saying that NLP is now the major use case for them. So even kind of like for machine learning in general, it's it grew pretty fast.
Yeah, it's the moment for NLP, and it's growing and growing. So for people who have joined recently, we are just waiting for all the people to show up. We will start in a few minutes. Okay. Yeah, as I was saying, it's an exciting time, and you guys are at the center of it. And I'm happy that I got to know you guys and I was associated with you, and I could set up this talk so that we can have this interest answered. Yeah.
Oh, there are 42 participants, quite a lot.
Yeah.
But it would be just a couple of us.
No, it's gonna be more than this. So one question. What do you think of the future of GPT-3? Is it gonna be widely accessible the way that other models are accessible, or are they gonna only focus on the API that they're building and it's not gonna be exposed as much as the other models?
Yeah, so far, I think what they've said publicly is that they didn't want to release the model. So there's a big chance that it's never going to be available as an open model, unfortunately. I believe there are a lot of there's going to be a lot of people either trying to replicate, or how the state of the art works, right? You have the state of the art for like a couple of weeks, and then there's a new model that actually does better. So I wouldn't be surprised if we find the same capabilities. We already find a lot of these capabilities in other models already, right? So I mean, it's going to be interesting to see. I mean, I'm super happy that it's really making a lot of noise these days. It's super awesome for the field in general of NLP. People are starting to realize the potential of it, all the different use cases that they can do. So it's great. It's really kind of like a great thing for the NLP domain in general. So and they did a really great job. I think OpenAI built a really great model.
Definitely.
Cool.
I've seen many people who don't have backgrounds in NLP, and they are very excited about it because of GPT-3, and I think it made the public closer to NLP. It has been out not very long, so we are only seeing the beginning. Hopefully, in the future we will have much more interest in this. Right. So I think it's a good time to start our talk today. So let me give you guys an introduction. So my name is Reza Sohrabi. I've been with the Citrix since January 2019. It is my absolute honor to have Clement as our speaker today. I had the pleasure of knowing him when I wrote a blog post on our Stitch Fix blog, and I mentioned that I've been using their repo named PyTorch pre-trained BERT at the time, and right now it's called Transformers. And Clement reached out to me, and we went from there. So it's been my pleasure knowing him, and these guys have been doing the great work that you see. The explosion of interest in NLP is partly due to them. And without further ado, I give you Clement, and let's go.
Great. Hi, everyone. Thanks so much for being here. Just to let you know, I've opened also the chat window on my laptop. So if there's any problem with the sound, if you're struggling to hear me, just let us know. As you can hear, I have a very strong French accent. I'm from France, so sometimes it doesn't help either. So feel free to let me know if you struggle to hear me well in the chat. So as I was telling to Reza, what I wanted to do today is giving you kind of like a little bit of an overview about NLP, about how important I think it is, on what kind of use cases are enabled by NLP, And then after that, I'll open up to questions, because I'm sure it's going to generate a lot of questions, to make it a little bit more interactive than the presentation. And before I start, I wanted to give a little bit of background about us, about Hugging Face. We're based in Brooklyn and in Paris, a little bit distributed, obviously, these days with coronavirus. We raised a bit more than $20 million from really good investors, some of them on the East Coast, some of them on the West Coast. I actually got my hat when Kevin Durant was still on the West Coast, before he moved literally 3 blocks away from where I live in Brooklyn. So now I'm pondering if I should switch to the Nets or stay faithful to the Warriors. And we're mostly known for our open source NLP library, Transformers, which is now the most popular open source NLP library. We've been lucky to have been mentioned in more than 1,500 research papers so far, and have more than 1,000 companies that is using our open source in production. And I wanted to start my presentation by stating something that is more or less controversial, depending on who I'm talking to. Maybe, I don't know if we have the Zoom voting feature, but maybe we could do we should do a vote on this feature. Who's thinking, like, if you can put like how does it work with the vote? Do we have the voting feature, Reza, or no?
I don't think so, because it's a webinar. I don't think we have.
All right. Well, then maybe on the chat, if you think that NLP is the most important field of machine learning, put a thumbs up. And if you don't think so, put a thumbs down, for me to see what kind of convincing I'll have to do during this presentation. All right, we have a lot of thumbs up. No, I haven't seen so many thumbs down yet. Thumbs up, thumbs up, thumbs unsure. All right. All right.
One of your panelists is a thumbs down. I'm not afraid to admit it.
All right, great. So let me continue and start, obviously, with just defining the topic. As most of you know, natural language processing is the branch of artificial intelligence focused on understanding natural language, right? So usually a good way to characterize it is to separate it and compare it to other domains like computer vision or self-driving or time series. And if you look at, if you take a step back and try to think about where natural language is used, you realize that most of your day is actually spent in natural language. Obviously, right now I'm talking to you in natural language. Hopefully, when you're going to be able to hang out with your friends and chat with them, it's going to be natural language. If you're reading the news, if you're exchanging emails, if you're browsing the web, most of your usage is in natural language. And even some other activities that you wouldn't think of as mostly natural language, like TV shows, watching movies, you can see that if you remove natural language from it, if you remove dialogue, they don't really make much sense. So you are spending most of your day in natural language. And if you think about companies like Citrix or others, you also realize that they're built around natural language, from things like customer support. Obviously, if you think of it like customer support is an input of natural language and an output of natural language, from sales, customers, kind of like interaction, customer reviews, internal communication. Your Slack is obviously natural language, or any sort of like coordination, communication, or even external communication to the rest of the world. All of that is natural language. And if you think of these domains, these departments in companies today, historically, they've been really human intensive, I would say, with very, very low technologies. If you think of these departments, especially at larger companies, they are very large human intensive departments with very little technology in it. So kind of like a high level point here is that natural language is very much the interface of humans, and it's every single thing that you are doing all day, every day. And if you take a look at what happened with natural language processing on the science side, on the technology side, it took a very massive switch a few years ago, thanks to a couple of major technology trends. Obviously, we've been having more and more compute available. We have more and more large and open text data sets. If you think of the web, it's basically a massive text data set. And what we believe is the last piece that was missing to the puzzle here is transfer learning that really started to prove that it could work on the domain of NLP 3 years ago, around that, mostly with the first paper being attention is all you need. And finally, thanks to that, you're now able to do transfer learning for NLP at scale, where basically you train a model on a very large data set and then are able to fine-tune this model on smaller data sets for specific domains, specific tasks. And what it led to is a pretty insane progress that you can see interpretation and a proof of in science leaderboards. So here I put the evolution of a benchmark that is called the GLUE benchmark, which is an aggregation of different classification evaluations. And you see that from May 2018 to June 2019, so a very drastic improvement. And one of the things that is really interesting here is that the human baseline is actually, I think, at 87 on this evaluation. So I'm not saying here that all NLP is human level today. That is not true. But the very fact that you can reach a human baseline, even on a specific evaluation, on a specific benchmark with specific data sets like that, to me is super exciting and super, super promising. That's something that we would never have thought of 10 years ago. And it happened not only for classification tasks that I've showed you before, but for a bunch of different NLP tasks with the exact same type of transformer models. So here, for example, I put the evolution of the state of the art on Squad on a task that is called question answering, which is basically you give the model text, document, any sort of document, you ask it a question, and then it's going to tell you where the answer is in the document. And the interesting thing for these specific science leaderboards is that the authors of Squads, when they saw that happening, they were like, fuck, we have a problem. Actually, these models are optimizing for these leaderboards or like are overfitting. We don't have the right evaluation because, as you can see, the performance increased too fast, right? So they decided to release a new evaluation called Squad 2.0, and that's what happens. As you can see, the beginning it was harder, so you stayed more at around 70, but then progressively got back to the 90 performance that you had on squad 1.0. And the interesting part here, and kind of like what it shows to me and to a lot of people, is that we're finally ready to move from a world where only humans could understand natural language to a place where now models can start to classify, understand, generate natural language too. And what's really interesting here is that probably because of the nature of the technology, because most of the complexity is hidden behind the weights, the progress, and it's pretty unprecedented, of the state of the art made its way really, really fast in the industry, in production. So you take a look at BERT, for example, just a few months after it was released, it started to show up in production in real use cases. The path from science to production has been insanely fast. So I wanted to show you a couple of examples of these transformer models in production today with real companies, to give you an example of what they're capable of doing. The first big typology of tasks that these models are solving is text classification. So you take any sort of text, it can be like an email, it can be a news article, it can be a comment, it can be voice to text, and your model is going to be able to classify it either for generic classifications or for your specific classifications. So here, for example, Monzo, which is a bank based in the UK, I think they raised a bit more than $200 million. They received an insane amount of customer support emails. They're using transformers to classify these emails based on their priority, and then they'll be able to act on it accordingly. For example, if the priority high, obviously they'll want to answer them right away. Or if the department is credit card, they'll want to route this email to the specific team. And it can be any sort of classification. Another big typology of final use cases by companies is information extraction. So from your text, you will extract any information that is present. So here, for example, extracting that George Washington is a person versus a location, extracting the date, extracting the topic. For example, to integrate it in the product, here it's Chegg, and add, for example, hashtags or categorizations of the different homework. Chegg is a homework platform that is uploaded into the platform. Another big typology of usage is question answering. I know that Reza actually played with this use case a little bit at Stitch Fix. You give it any sort of document and then ask a question, and the model is going to tell you where the answer to this question is. So it's live today on Bing. If you try to ask a question in natural language in Bing, the answer in the first paragraph that is shown to you is powered by transformers today. Another use case is text generation, text summarization. So you've all experienced with the autocomplete in Gmail. You can also think about a use case where you have a share price that is moving and automatically it generates a paragraph about that for analysts. And you can think about it the other way around. A lot of companies are taking large chunks of text or news article, for example, and generating a summary about this news article or about any sort of text. And the last one is conversational AI or chatbots. Obviously, Alexa, Siri, you all know that. Square is a good example too. They're using transformers for their customer support chatbot. And what's super interesting here, and that's kind of like I want to kind of like finish the kind of like more presentation part of this talk, is that we're seeing this very, very cool virtuous cycle where the more companies are building some science and proving some impact on the science side, the more they enable new use cases in production. And the more they prove the value in production, the more they invest into the science to improve these models. And so I think that's why the NLP domain moved so fast over the past 3-4 years. There's really kind of like this machine where companies are investing more and more in science, making progress, showing that you can do more and more with NLP, and then integrating it into the product, getting more results, and then as a consequence, investing more in science. It's very much what we've seen at Hugging Face. And now I wanted to take a little bit of time to give you a little bit of a demo to see how easy it is to use all these NLP models today. So if you go on huggingface.co, you'll see all our, I think we have 2,200 models added by NLP researchers to the library, including some of the popular ones that you might have heard of, BERT, GPT-2, Roberta, T5, distilled version of these models. And what you can do is look for a model that works well on your specific task. So let's say, for example, I'm taking text classification, right? Then you can pick like a language, or you can pick a framework that you're working on. And then, for example, I'll take this model, which is emotion understanding classification. And just like that, you can start running some inference on this model thanks to our inference widget, and use that also in your product right away. You can also use it from our open source literally in a matter of minutes thanks to this. And if you want to start like fine-tuning, pre-training it, or adapting it to your use case, you can do that too. And finally, I wanted also to show you 2 other demos that we released, which I think are pretty cool. One of them is on zero shot classification, and it's showing you the capabilities of these models on classifying any sort of text, right? So here, for example, you have an article and you're inputting yourself classification labels, and then the model is going to classify for you. What's interesting is that this model hasn't been trained on this specific classification task, but it's performing zero shot classification based on what it learned in the past. So for example, if I take something completely different, I'm gonna take maybe something from Stitch Fix. If I take, all right, I'll take maybe, where do I get, for example, a big text that I could try to classify, Reza? Maybe I can, maybe in one of the guides.
Maybe, I'm not too sure.
All right, I'll take that, for example.
Yeah.
All right, I put it here, right? And for example, what can I try as a classification for us?
Fashion.
All right, fashion versus
science.
Science. All right. All right, yeah, it got well, like fashion, or, and you can even like, how can I do that? For example, women clothes, men clothes, something like that. So obviously it's not like a categorization that has been seen in the model. but still it manages to predict it pretty well. All right, please check black, white. Why is there a notion of black, white? Black, white. I don't really know what it would mean here, because there's not really any mention of it. But so that's a demo I wanted to show you. And another one that is also pretty cool is the ability for question answering. And I know Reza is going to be excited about that. It's long form question answering performed on something that is called Li5, which is on Reddit explained to me like I'm 5. And what it does is that it generates an answer based on different sources of information. So here, for example, it's drawing from a couple of like different Wikipedia articles and taking from there and generating an answer to it. And it's pretty cool for 2 aspects. First, it's able to answer very complicated questions that most models wouldn't be able to. And the second one is that it shows you where it drew from. So obviously in the context of like for industry context, it's super interesting, because if you manage to do like, for example, customer support and be able to redirect people to more resources, for example, if the answer is not satisfactory, it's a pretty good flow for users. And you can test it on the first questions, but also on like any questions that you want to try, how you make chocolate. Okay, let's see here that it's taken from different articles. I can take on these demos if you have any idea of prompts or things that you wanna test. Feel free to let me know in the chat. I'm happy to test for that. It might not work most of the time, right? That's the fun with these models, but happy to try. So yeah, I think that's pretty much it for kind of like the more like presentation part of this talk. I want to keep some time for like questions. So if that works for you, Reza, we can move to questions.
Yeah, for sure.
Or was there anything else that you wanted me to cover?
Yeah, I think that's about it. We can move to the question and answering section. If you have more time after that, you might want to talk about other things that you had in your mind. So let's go for questions. Please write down your questions and we're happy to answer those.
I'll start us off. So you showed us like the cool demos and you showed us like how much is like built into this, but let's say we have an app that we're developing and we want to put something like this in the pipeline. How do we get started with like this to do that? So for example, I'm developing an app and I say, you know, I want like text summarization to be like one of the things that my app like does, you know, just as like a part of the product.
Yeah. All right, so if you want to do that, you basically go on huggingface.co, then you look for your use case. So here, summarization, right? You make sure it's in your language that you want. So like, for example, let's take English here. And then you kind of like, look at a little bit of the models. You look, for example, they all have like descriptions, you know, like, so you look if the metrics is good for you, if there's some context about it. Then you can test here. Oh, the model is not loaded yet. So let me just go back and it's going to take, so the models are loaded for the inference on demand. So sometimes they're not loaded. You have to wait for a few seconds for them to be loaded. So here it's currently loading. Let me take another one. Maybe we'll just wait for a few seconds for it to load. All right, so here you can start seeing the, so from this text, it generated this summary. So you can test it on your use cases, you know, like typically what you're expecting your users, your app users to do, see if it works well. If it works well, it's as easy as integrated as an API call. So really, in a matter of minutes, you can add these API endpoints to your product, and we're going to run the inference for you. If you realize that it's not working well for your use case for a couple of reasons, then usually you have to, you know, either like train your model, fine tune it on your specific domain, on your specific use case, on your specific like classification, for example. So you can go to our open source. So on GitHub, our main library, as I was saying, is transformers, and then you have tokenizers and NLP. And basically, yeah, use our quick start to understand how it works, how you can train a model to work on your use case. And once you will have trained the model, it's going to appear right here in our model hub. So you'll be able, the same way you did for another model, you'll be able to use the inference API to add it to your app. Or if you want to develop this expertise yourself, you can like run it yourself if you feel like spending the time there. Does it make sense? Does it answer your question?
Yeah, totally. That seems very easy. Thanks.
All right.
Yeah, it's very much like the beauty of these models. They're very hard to pre-train, but now, especially with most of the complexity being hidden with the weights and with services like our serving APIs, they're very easily integrated into your product, very much as something that is much simpler. And I think that's why so many of these models got integrated into the production at insane rate and really fast.
Yeah, I was gonna say that people can raise their hands and I can unmute them and they can talk if they want. They can also send us the question through chat. So currently we have one open question. Do you see it, Clement?
Yeah. Do you have models that can write the ingredients, recipes that make biomedical assays chemicals? That's a good question. I don't know what all the models are anymore in the hub, because there are like dozens of new models every day added to it. I know that we have a couple of like recipe models, right? So for example, this one, let's say if it works. All right, so it's kind of like a Hugging Face cake recipe. So maybe we can try to do something like, what was your question? Medicine? We can say COVID medicine. I don't know at all if it's going to generate anything like meaningful, but all right, here it's telling you that. All right, guys, we just made a breakthrough here. Don't tell anybody because we could probably make a lot of money out of it. But yeah, so you could probably play with things like that. I know that a lot of people are using transformer models for molecule generation because it's sequences that are like a bit similar to language sequences, but they're obviously training their own specific models to it. And from what I understand, it's still on the science side. So it's not ready yet really to be used in production, because a lot of the problems with the current NLP models is that they're not so good at pure accuracy. You know, like they generate good text and you can guide them, but sometimes they will make mistakes. And typically in the medical industry, most of the time you don't want to make mistakes. So they're not always like the best tools to use. But if you send me, so my email is Clement, my first name, like that, at huggingface.co. I'll actually put it in the chat. So if you send me your use case, happy to do a little bit of research and see if there are people that are working on similar topics that can be of any help. All right, so another question from Natalia. Thanks for the talk. What are your thoughts on biases in corpora used to train NLP models? Gender, race bias in Wikipedia and Reddit. What are the responsibilities of researchers and engineers with respect to these biases in the data and in the models? And how do you see the role of Hugging Face in this work in particular? It's a very important topic. We have a couple of people at Hugging Face that are really actively working on that. It's a very complex, obviously, problem. We're trying to focus a lot on education for these problems, which is one of the reasons why we're publishing a lot of demos, is for people to be able to experience by themselves and test these biases and see what kind of biases are there. So for example, we've shared it with a lot of like organizations working really hard on the topic for them to help detect biases. We have a lot of tools that are integrated in the ecosystem to start to analyze a little bit what's happening. It's far from perfect, to be honest. We're still really very much at the beginning of detecting biases and making sure that these models perform better. Our role at Hugging Face, we're thinking, is really to keep focusing on the open source and make these models available and open for everyone to be able to assess them and do the research around biases. We don't believe in a closed approach to research on these topics, because we believe that actually if you keep these tools only at the hands of large organizations, which is the case if you don't open source them, right? You'll have only like basically Amazon, Microsoft, and Facebook and Google having these models and nobody else. And they haven't proved to be the most ethically conscious players, unfortunately. We believe it's not a good thing if you leave these models only to these people. So we believe it's good to open it to everyone, for everyone to be able to look at what they're capable of doing and where they're failing, to hopefully progressively make progress and counterbalance some of these biases and find solutions to these biases. Another question from David: how flexible are these to non-standard applications? Jason, how does your methodology compare to Object-to-Vec in AWS? So I'm not entirely sure what you mean by non-standard applications. You can use our API, whatever the technology you're using, if you're using more like other kind of technologies. So maybe if you can reformulate that, because I'm not sure to understand your question. On the other one, how does your methodology compare to Object-to-Vec in AWS? So I haven't tested it in a while, but thanks to Vec, Object-to-Vec, all this typology of models are kind of like older generation of models. They came out like 2-3 years ago. For a lot of the use cases, the more modern transformer models, like BERT, T5, GPT-2, XLNet, are working better and giving you a better accuracy for a wider range of NLP tasks. You can use most of the models as just as features. So, for example, if you go on our pipeline in transformers, all right, let me go down. All right. Pipeline. So our pipelines are our way to simplify. It's a layer of abstraction to simplify the usage of transformer. You have one of the class, which is a feature extraction pipeline that can be used more or less similarly to more like object to vec, sense to vec type of models. That is going to help you, for example, to compute like similarities between different NLP strings. Another question from Jaya: what are transformers? Can you explain a bit about that? Yes, I can give a little bit of the high level. I would highly recommend to read the paper "Attention is All You Need," which is very much the foundational paper for transformers. That is a really good read. If you see my screen here, I took this schema on the right. The way transformers work is that you're going to do a large pre-training on a task that can be either masked filling. So you take like a string of text, you remove a word from this string of text, and you try to predict what is the missing word. Or on language modeling, meaning that you have a sentence and you're trying to predict the next words. And so you do a very large pre-training on a massive data set, basically a slice of the web, on this specific task of language modeling or like mask filling. And then what's really interesting here is that what we realized is that this huge model actually embedded a lot of the learning that you can use then on different tasks and different domains, right? So after that, if you fine-tune this model, or if you gave this model a little bit of data, you'll be able to perform any other type of tasks like text classification, like information extraction, token classification, emotion understanding, question answering, by basically transferring some of the knowledge that has been done during this massive, large pre-training with a smaller data set for your specific task and your specific domain or your specific use case. So that's more or less the underlying or the high level of philosophy between transformers and the way transfer learning for NLP is finally working. So massive pre-training on one task, mask filling or language modeling, and then small fine-tuning or zero-shot, few-shot learning on other tasks or domains. Catherine is asking, how do you communicate the limitations of the models and where they should and shouldn't be used? Are you using the model cards framework or something similar? Yes, we're encouraging every researcher to add the model page to their models on the Model Hub. As you can see here, there's a model card missing, so that's not a good one, but a lot of the models will have the model card where they can talk about the ethical bias, for example. So we really encourage that a lot during the process. Also talking about the limitations. We also believe that by giving people an ability to try these models, they'll also be able to see the limitations themselves. And we're super open about it. That's why I like to do a lot of demos, because, and I like to do demos that are not like cherry picked or like I know what's going to happen. For example, I tried like COVID medicine, it could have not worked at all. But that's a good way. The widgets and the demos are a good way for people to discover by themselves the limitations. At Hugging Face, we want really to help the community and to empower the community. We don't believe that one single company will be able to build the best NLP model and it should have the responsibility for everyone. We believe in our ability to provide tools for the community to contribute and to understand and make progress on understanding not only the potential of these technologies, but also their limitations. Wondong is asking, are there any recent approaches that you find interesting and promising for taking the next step in growing NLP models, whether it be architecture or be training algorithms? I'm interested in your observations and thoughts. Yes, we believe we're still at the very beginning of what you'll be able to do with NLP. Two big topics that we're working on really actively right now are, one, extreme sparsity. So we released DistillBERT, which is arguably the most popular distilled NLP model out there that is in the hub. I'm going to show it to you. That is faster because it's a distilled version of BERT. So here you see for mask filling, right? So predicting the word that is missing here, it's taking just 0.072 seconds on CPU, which is pretty impressive. And we released a few weeks ago a new method for pruning that we call movement pruning, that we believe is very promising, and we expect to keep investing more and more efforts on ways to take these massive models and run them in production. And the second thing that we're working on really heavily that we think could be a next step for these kind of models is the integration of structured knowledge into the representations. These models are really good at pattern matching, but they're still struggling with accuracy and integrating more like logical approaches that are usually embedded more in structured data sets rather than unstructured data sets, or at least that are easier to learn from structured data sets. So we're working a lot on kind of like how you can mix the current approaches with more structured, logical kind of data sets or knowledge bases that we believe could be really impactful for the field. We're lucky to have a really great research team that is led by Thomas Wolf and Sasha Rush here as like authors of the paper with Victor San and many other great people. And we're trying to empower the whole science community to iterate faster and faster, research as much as they can. And I think it's amazing what the whole community has been doing for the past few years. And we believe they'll keep making pretty insane progress in the coming years. We're just at the beginning of it for us. Delip is saying, nice talk, Clements. Why did you guys call yourself Hugging Face? Cheers. That's a good question. We were always joking that we wanted to be the first company to go public with an emoji rather than with the 3 letters that you usually see from public companies. So we absolutely wanted an emoji as the name for the company. And then when we looked at all the emojis, we felt like the hugging face emoji was a pretty good kind of like image metaphor for NLP, because it's not human, right? It's an emoji, the same way NLP is a technology, but at the same time, it's showing the hug, which is a very human behavior. The same way, you know, NLP is a very human practice. So it was a good kind of like image for this like technology meets human thing. So that was making a lot of sense. And frankly, we were using the emoji a lot. So we felt like it was appropriate. We added the mask to eat during the beginning of COVID, to kind of like show people that even if our name and logo is a hugging face, unfortunately it wasn't so safe to hug these days, but hopefully in the coming months or coming years, once we find a cure for COVID, hopefully it's going to be safe again to hug, and we'll be able to show more proudly our hugging face name. All right, another question from Ronte. Any work to detect real versus fake news using some consistencies in the corpora and published body of knowledge? So there are a lot of interesting work on the topic that you can use right now that is connected to transformers. One of them is the OpenAI detector of that is based on Roberta, that is starting to look at how you detect. So it's more like here AI generated text versus non-AI generated text. So it's not exactly fake news. I've seen other models in the hub and other companies. I think it's Coinbase, which is using transformers to detect fake news. So they fine-tune their own model to do that, and it's live in production. So it's apparently working pretty well. I don't know if we have any public one. Let me try to news. Yeah, we might not have public ones, but I know that a lot of people are doing like private ones, and it seems to be working pretty well. In addition, obviously, to humans, especially if you're like in a critical function. I wouldn't recommend Twitter to completely switch to a machine learning based approach for all their moderation, but it can be used maybe in addition to human moderators, and I know that a lot of companies are already using these types of models. David is asking which tools of yours can perform well on generic JSON training rather than free text. Maybe should I email you? Yeah, you should. You should probably, because it's a specific use case. I know that they are working well on a lot of different kinds of input. For example, this one is a code language detection model. So for example, if I take example of JavaScript code, right, and I take, all right, I'll take that. All right. Put it here. All right. So it can predict, and here I think it's trained on the data set that is no, it's email, but we have also like code data sets in our library. Something I didn't mention before is that in the hub, you can also obviously see all the models, but you can also see all the data sets. So I think there are like 150 like different public data sets that models are trained on, and also the metrics. So it's kind of like a very comprehensive system. So you can go from a metric to a data set and then fine tune a data set. But David, yeah, you should definitely like email me based on your use case. I can give you some pointers. All right, Jivitesh is asking, how do you and your team keep pace with NLP research? That's really hard. That's really hard because everything is moving really, really fast. We really rely on the community. So we communicate with everyone. We are trying to empower people more than thinking that we can do everything ourselves. So it enables us to keep a pulse of what's happening. Obviously, looking at our model hub, looking at how people are contributing helps us see where everything is going. What advice I would have to do that is to follow our Twitter at Hugging Face, where we posting a lot of like the latest things that are happening. Go to our forum, where also like you can see a lot of the things that are happening there. And then find a trade-off, you know, like depending on your position, depending on your goals, what you're trying to achieve. You don't have to be always like aware of the latest thing. You can kind of like try to find a signal amongst the noise. And sometimes kind of like dig deeper on a specific thing that makes sense for you. Don't know if I have other recommendations. Maybe Reza, do you have any other recommendations to help people keep pace with NLP research?
Yeah, of course. My method is to follow a bunch of people on Twitter that are good people that share recent research, and it's all by chance, but most of the newest stuff and interesting stuff would surface to me through Twitter.
Cool. Is Hugging Face currently working on something similar to GPT-3? A lot of people in the community are working on several things. There are already a lot of models in the hub that are performing well in similar tasks to what GPT-3 is doing. Hopefully at some point, OpenAI will be able to release GPT-3 publicly, and then it would be integrated into transformers, obviously. It's as I was telling Reza at the beginning, it's really awesome how GPT-3 is showing more people how they can use NLP in different contexts. So it's a really great model. It works really well for like a few shots, zero shots, text generation, and hopefully it can be really successful for more and more people to use NLP in the future. All right, anonymous attendee is asking, what are your thoughts on GPT-3 and the recent demonstration of code generation? What is the future of this space? I think code generation is a really cool demo. I haven't been able to try the actual code generation because most of what's been out there for the moment has been always like GIFs or like videos, and hasn't been live yet. So I'm really looking forward to actually try the thing, you know, because sometimes with NLP, I mean, we talked about it before, it's easy to engineer like a good demo and do an impressive video, but then when you try it more extensively, it doesn't work as well. I think it's too early to think about NLP as something that is replacing developers, because it's going to make a lot of mistakes. You know, maybe it's going to work 1 out of 3 times, but then does it really save you time as a developer? Probably not. And for most of the things that you want to do actually in real use cases, you're usually better off writing your own code. Maybe it can help you a little bit with like autocomplete, or like help you a little bit in debugging or things like that. But we're fairly far from having these models actually replace developers. It's not going to happen anytime soon. So it's still to be seen exactly what's the use case there, how you can actually apply that. One of the problems of these models, and it can be counterintuitive for people coming from different types of technologies, they're very easy to get to something that looks powerful and close to achieving something that works. But the last like 90% of accuracy are almost impossible to get. So for example, for a normal kind of like software engineer, when they play with a new model and they make it to generate something that looks like code, or like is close to something that could be working, their understanding is that, all right, it works already out of the box, I'll fix a couple of things, and then it's going to replace the developer, right? The problem is, because that's how it works on kind of like the more, the previous generation of technologies, right? If you had something that works, almost works, it's easy then to kind of like get the last final things for it to work completely, 100% of the case. Here, to have this 10 additional % of accuracy work, and for it not only to look like code, but actually be functional. I mean, it's not just fixes. It's not just like incremental improvements. It's like, I mean, it's training like GPT-10, which is like decades ahead and billions of dollars of computes ahead. So that's sometimes the challenge. So I would recommend to obviously be inspired by demos and by videos of what it can do, and it's great. It shows great promise, but also take time to focus on actually how it's going to be used, what kind of use cases it solves, how does it save time or not, in kind of like more down to earth kind of applications. Or if you're interested in building an AI that is going to replace developers, go into science, you know, like start a PhD on the topic, and hopefully you can contribute to the field, and in a few years we'll be able to get there. We're not there yet.
Cool. Question, Brian?
Say thanks, I gotta run. Thanks a lot.
Okay. So at the end, I want to thank all of you guys for attending this webinar. I want to thank Clément for his great presentation. And as Clément said, if you have any questions, reach out to him through email. Thank you so much.
Sounds good. Thanks, Teresa. Thanks everyone. And yeah, feel free to reach out. My overall kind of like high level thing is that NLP is really like up and coming. So many things are happening. We're starting to see everything that we can do. So if you haven't taken a look at what we're capable of doing now, in a while. You know, for example, if you looked at NLP like 5 years ago and haven't looked at it seriously since then, I would recommend to now take the time to look at it again, try again, because a lot of things are happening, a lot of use cases are appearing. Every single company is adopting NLP right now. I see that from the thousands of companies that are using our open source, Stitch Fix including. So take a look at it, try to contribute if you can. That's going to be very exciting in the future too.
Yeah, huge plus one to that. All right. Thank you, everyone.
Thanks, everyone. All right.